events. We define mutually exclusive events as events that have no outcomes in common. So no outcomes in common. Let me just see if I can get a line over there. They have no outcomes in common, right? They're essentially called mutually exclusive events. What are they called? Mutually exclusive. In short and in summary, and in simpler words, it basically means these are events that cannot happen at the same time. Okay, so for example, let's talk about our deck of cards. Can something be a king and simultaneously be a jack? Okay, can it be a king and be a jack? It cannot be a king as well as a jack, and so therefore being a king and being a jack is considered a mutually exclusive event. Okay, if we talk about rolling a regular die, you cannot roll the die and land on a 3 and simultaneously at the exact same time land on a 3 as well as landing on a 1. You cannot do both, and so therefore we say the probability of rolling a 1 or rolling a 3, these are considered two mutually exclusive events, right? So how do you get the probability of an OR statement? In other words, the union for probability of rolling a 1 or rolling a 3. It is simply equal to the sum. Remember, this has to be true or this has to be true. Any one of them can be true. So your chances are up here when you have an OR statement. It's going to be 1 out of 6 plus 1 out of 6, and therefore it is equal to just simply 2 out of 6 or 1/3 or 0.33 recurring. Okay, the same applies here. This will be 1 out of the probability of drawing a king and also drawing a jack. Okay, it's a little bit different. Probability of king and jack, and you can tell me what's the difference that you see over here. This is again called the intersection, which is represented by a symbol like that, and this is represented by the symbol like that. This is like an upside down U, which is called the intersection, right, which stands for and this is the union, right. We'll deal with this in a little bit more detail later on as well. But nevertheless, for mutually exclusive events, the one test that we have is that we can take the union and we simply add up the probability thereof, and we know that it's true. The other test that we can do is we can check the intersection, because we know that these two events, a king and a jack, cannot happen at the same time, and therefore they're mutually exclusive. So if I ask you what's the probability of getting a jack and also getting a king at the exact same time, you'll tell me that there's a 0 chance of that happening, because there is no king that is also a jack. Okay. So hopefully I have explained this well, and please do go through the video set again if this seems challenging. Okay, which have no outcomes in common are called mutually exclusive events, right? And if you are asked to calculate the union, the probability that one event or the other event occurs, and you are given that those events are mutually exclusive, then you can simply indicate that you can take the probability of the one event plus the probability of the other event, as seen in our example over here.